Alright guys, welcome to today's show. So let's see if we can create this send IP function. So we can remove this stuff. And we're gonna have a bool send IP and int32s, and we're also going to have the IP packet. So let's call this the packet, since it's the main thing. Okay. Okay, so let's see. We need to have some kind of a pointer to this buffer we're gonna use. But first of all, let's double check that we have what we need. So if we don't have an S, or if we don't have a packet, we can instantly return false. And what variables do we need? We need to have an int8, and this is going to be the raw packet, so let's just call it raw like this. We probably need a couple of int16s for dealing with stuff like sizes and such. So let's say we have an n for now. And let's also grab this signature for the send2 function, because we can use a whole bunch of different system calls to send IP packets and the likes. So there's send and send2 and send message, and they all work slightly different. For instance, send message requires us to fill in a huge structure, and send is probably more like regular TCP connections. But send2 looks promising, because here we can just provide the file descriptor, a buffer containing the data we want to send and its length. Flags, I don't think we're going to use those. We need to check that out. And here we will put the addressing info, but since it's going to read it from our header, we probably don't need that. Excuse me 1 sec, I just need to take a sip of water. Alright, so let's copy this signature like so. Let's go into here. There we go. Okay, so if all of this is in order, first we need to evaluate this IP packet. So raw should be equal to eval. I think we can just do eval, or not yet. So let's do eval, because with the other one, the show function, we have this kind of thing. So it automatically acts depending on what data type it is. So why not create one for eval as well? We can just copy this, paste it. Okay, that's not good. Okay, that's better. So this should just be eval, and if we have an IP, we want to run eval IP. What's the arguments, by the way? Okay, it just takes one. So we don't need this first thing. We do need this though. Maybe we should do this. Same here. It usually don't matter, but if we are providing some bigger expression, we want to have that support as well. So let's remove this, and this is going to be eval icmp. And that's it, I think. Alright, so now we can just do raw is equal to eval, and we provide the packet. And now we should have the packet prepared and ready to be sent. Kinda nifty, eh? We do, however, need to calculate the length. So let's see how we do that. We should have created a function for that. Because, let's see. First of all, we have this regular thing, but then we have, well, we don't use the options. But we do, however, have payload. So, let's see. We need to go into this icmp packet. Well, let's see how we did it in the example. So we make an icmp packet, we make an IP packet, and then we evaluate the IP packet, and we calculate the size as the size of the structure plus the size of the icmp structure plus the payload size. Alright, that's not too complicated. And that's why I always save the comments and tests like that. Okay, so let's say our n is equal to the size. Let's do this. Or maybe even this, just to make it so readable as possible. So we take the size of a struct s raw IP, and we plus the size of struct s raw icmp, and then we plus the packet and its payload, its size, I think. Let's double check this. So this is our IP. So we go into the payload, which is of type icmp star, which means this whole thing, and we do have a size field. Perfect. can even check if, no, need to double check that the n is correct. So now we have the data and we have the size. And I suppose that's all we need. Let's do like this. We will end the comment here instead and save 2 lines so we can put the code here without scrolling. We need to take care of the return value as well. So let's say we have a signed int ret. Which should be equal to send to. We provide the int version of our s, which reminds me we did it wrong somewhere. Where was that? Maybe not. Okay. So that's our socket. Then we need to provide our buffer, which is just the row. And then the length. So that's our integer version of n. And flags. We need to think about that. And then we have this one. That's the address. But I don't want to provide it here. So can we do, it's a const. Well, maybe we can just say, let's try this. So we do const struct socket address and a 0. And the address len will also be 0 then. So this is our send call, I guess. By the way, let's clean out this printf right here. Okay. So we should be able to we can start by checking the return value, and I guess this should be a positive return value, since it usually tells how much we were able to send or how much we tried to send. Byte sent or -1. Okay, so let's check for -1. So if our ret is less than 0, what are we going to do then? I guess we will just let's just return false. Otherwise we can return true. Doesn't have to be more complicated than that. I already know how many bytes I'm trying to send. Okay. So we need to check this out. Is there any flags that we are wanting to need? Good English there. The flags argument. Message confirmed. Don't route. This one. Don't wait. So we do it non-blockingly. This we do need to use at least for the when we listen for the packets. Otherwise, we cannot really deal with sending multiple packets at the same time. But at this stage, it's easier to test stuff if we do everything sequentially. So let's do something like this. We set it inside of a comment like this. But for now, we'll just put 0 here. Like so. Okay, let's see if this compiles. It does. It did. Nice. It's not often it compiles on the first try when you try to do completely new things that you have never done before. I have never worked with these sockets, and I'm writing this program now for the first time, so it'll be interesting to see if it works. So now we can use our first main again. So let's call this main 2, and this is main 1. And let's at the bottom here create a regular main. So in main let's do this. And we'll just return main 1 argc. And how do we pass this thing then? Maybe it will evaluate that automatically if you just do arg. We need, however, to change a couple things. So after we have printed this out, we will set s equal to setup. If we don't have an s, let's just do this for now. But if we have an S, we want to try to send one of these packets. So let's create some variables. We need to have an int32s, and we need to have a bool ret. So ret is going to be equal to, and let's say we have, let's do send IP. And we only need to provide this and the raw packet, which is our, no, let's see here. How did we do this? I think it's did all the evaluations inside of this, didn't it? Yeah, so we just need to send our structure, that's good. And that is our IP packet. So IP packet, IP packet. I think that's the right one. Make IP packet, yeah. And then we want to print. And let's do ret is equal to and a string. And if ret is true, we'll do this. Otherwise, this. Yeah, something like that. And what are we going to try to ping? We are not going to be able to see if we get a response back, but we need, well, so it doesn't really matter. The only important thing is that we provide real IP addresses in the correct format, which we do already. So yeah, I think this is going to work actually, but we'll see, won't we? It compiles. Exciting stuff. And if we run this as non-root, we get the error like before. But if we run it as root, ret is equal to false. Okay, we are at least closing in here. So let's look at our strace. And what do we want to grep for? I guess send to is the interesting thing. Destination address required. So we do need to put it there, and after all. Okay. Well, that's... I'm sure it will look at our packet anyway. This is probably just so it can find the interface. Okay, so let's see. We need to modify this send function slightly. So this one, construct sock address, and then we will provide, let's say, sock. And this is going to be size of sock. And this should probably be a struct sock address in. Let's start by cleaning this out. So we zero out our sock, size of sock, and I guess the the actual IP address is all we need. So let's set our let's see. We should set our SOC SYN address, S address. And how do we store this kind of stuff? So inside our own IP structure, we have the destination as an int32. And this is in the correct network byte order already. So we should just be able to do something like so maybe we can even do let's not struct sock address how should we cast this thing? S address is an in address, I think. So struct in address. And then we give it our packet destination. I think this should be enough. Conversion to non-scalar type requested. So it's not in address. Let's check. If we go first to the sock address in, let's see if we can find that here. Sock address in, and this contains the in address. Okay, so this is of type in address. Well, we don't really need to go any deeper than that, I guess. So let's jump back one step. So we set the SYN address directly. I think we should be able to do that. Okay, it's still treating it as a struct. That's unfortunate. Well, let's try again. If we search for in address like this time. Okay. So the address in. In address T. So if we undo this, and we change this to in address T. Alright, this should fix it, I think. Yes, it did. Good, good, good. Let's try this again. Ret is equal to true. What do you say about that, huh? Ladies and gentlemen. And this is our packet. Looks right. As a family unspecified. I'm not sure if that is a problem, but I don't think so. And then we have the data. Yeah, 29 bytes. And an IP packet is generally 20 bytes, the header. Could the icmp packet be 9 bytes? Yeah, doesn't seem unreasonable. So possibly we are able to send this stuff, but we need to check. Let's see, do I have TCP dump installed? Okay, not on this machine. What about, let's see, air gap. Let's update the cache to begin with. And let's install TCP dump. If you don't know what TCP dump is, it's a packet sniffer which works very nicely. And let's see, we want to let's look for any packet from host and this IP address. And let's first send a regular ping just to see that we get it. And what address does this box have? It should be reached by this 10.1.2.6. Okay, that's only one IP address from the other one. But we did get a lot of garbage. Is it possible to do this, perhaps? Let's try it again. So 10.1.2.6. Yeah, we got it. Okay, so this was the regular ping. Let's see if we get something from our own. That's far more interesting. So if we just run this as sudo rets equal to true, and we got nothing. Oh, I forgot to change the IP. Phew. So let's see. We wanna, where is it? Here. We want to change this destination. This is 10.1.2.6. And we come from 10.1.2.5. Let's first try this. This is our real IP address. So let's try with this one first. Rets equal to true. Here we got something. Okay, IP invalid. Okay, so what does this mean? Either that we got an actual broken packet due to some header in the wrong order or something, or the checksum's wrong. But we are at least able to send something which it reacts to. So now there's probably just some bits wrong at some place or another. Something like that. I want to try something first. What if we don't send the icmp part of it? So we don't do this, basically. By the way, that reminds me. This is always thinking that this is icmp. The rest we have made generic. So we should probably do this generic as well. That's not right. Let's highlight this so I can remember to fix that. But that's not our current problem, though. So if we want to send just a regular IP packet with, let's say, an empty payload, then we can calculate for this, but we will have a raw IP and the size will be 0. And we don't give it a payload. Raw IP, raw icmp. Yeah, let's see what happens. It will still be type icmp, I think, so this should probably still trigger, but let's see if it does. Okay, that did not work very well, did it? So it's seg faults. Probably because it tries to evaluate the payload. Because we are telling it that it is an icmp, and now we're telling it it has no payload. So that's probably why it crashes. It shouldn't crash, of course, but it did anyway. Make icmp. It's probably somewhere in the eval IP here. Okay, so this is going to be true. Protocol will be 1. By the way, will it though? Because if we check how they did it when we tried to run the regular ping, so strace, no, not this one. proto icmp. Is this something which evaluates to 1? Let's check that. Yes. Okay. So that is probably not a problem now. Okay, so we set the checksum to 0. And the length, well, here is the problem. We calculate the length based off of the packet type. So it's kind of hard to send something completely 0. Alright guys, welcome back. So I have been looking through this a little bit, and I think I have found a couple of errors. So let's start by putting this back in the order we had it before. So let's remove these edits so we send the entire payload. I think that was it. This too. Like so. And now it should work, I think. Yeah, we get the error because we don't, we're not root. And I just wanted to see that it looked like before. But if we look closely, we see something weird at the end here. We have a couple of 0 bytes, which we shouldn't have, because here we should have the payload of the icmp packet, which we don't. And the reason for that, let's see, when we, let's go to the eval IP. When we turn the structure into a series of bytes, I made the calculation a little bit bad when I calculated the payload that we are copying into this. Because, well, first we eval the icmp, and that works fine. But when we copy this thing, I'm using the payload size as the number of bytes to copy. But we need to take the header into account as well, right? So instead of this, let's reuse our size variable and set this to the size of the raw icmp packet, raw icmp, and then we plus the packet payload size, like so. Now we can remove this right here. Size. Alright, so this is one of the reasons that this wouldn't have worked. Right, so if we recompile and rerun, now we can see that we are sending all the bytes that we should send. Okay, but this will still fail, because that's not the reason for the error. It took quite a while for me to be able to interpret that error correctly. But if we can use this small terminal here. I hope it's visible at least. If we run tcp dump and we want to grab icmp packet and let the source be 10.125, like so. And now we go here and we run this as root, and we get a true response. So let's see how this looks. Yes, we get this. And if we look at this, IP5 is invalid. And that's a very important clue. If we go into the raw IP packet, there's a lot of stuff going on, but the first two here, it's 4 bits with a version, and it's 4 bits with the the length of the header. And if we look at these this first 2 byte here, there is a 5 and a 4, and the size of the IP header, that's 20 bytes, and this is in multiples of 4. So 20 divided by 4 should be 5. So 5 is right, and 4 is the correct version of the IP, but they are in the wrong order, as you can see. And why does this happen? Because if we look at the code, they are in the right order right here. And if you remember, we need to use network byte order. And I mentioned that if we have 1 byte, we don't have to worry about that, because there's not two ways to express this. If we have 2 bytes, then we can express it like this, BBAA or AABB. And this we have already talked about. But what if we have half a byte, like here, 4 bits, 4 bits? Then it starts to matter again, because the system is only dealing with 1 byte granularity when addressing memory addresses. So both of these share the same memory address. And this means that we need to reverse these two. So if we were to say int 8 IHL 4 here instead and remove this, I think that is enough. Alright then, let's see if this works. Let's restart this TCP dump, and let's compile this thing. Let's see what happens. There we go. So we get an IP packet from this IP address to this host name, and this is the current box that I'm running this from. icmp echo request, ID is this, seek is this, length is 9. So now we are successfully able to send raw IP packets and icmp packets, which is kind of cool. There's one thing though. What's this ID and this seek? If we go to the Wikipedia page again, if we search for icmp wiki, and we scroll down to, I think, yeah, if we go into ping here. Okay, so this is the icmp header that we're used to, the type field, code, checksum, and all of that. But in the payload, where we're currently just sending some garbage, this is not the official standard, but this is what most uses. So we have a 16-bit identifier field, which is it's to, if we're running several pings at the same time, this should identify the process, so to speak. And the sequence number usually starts at the 1, and this will increase by 1 for each and every packet that we're sending. So we should use this stuff as part of the payload. So how can we do that in an easy enough kind of way? I think the best way would be to create a new structure. So let's say this is a ping packet. And here we're going to have a 16-bit field for the ID. And we're going to have a 16-bit field for the sequence number. And then possibly some data. So let's say int 8 data, like this. Because usually there is some random data or similar inside of this. Alright, so let's see. If we go to the code where we create this packet, it's currently inside of our main here, but this is temporary. And this is what we have inside of the packet currently. But instead of using this str as an int 8, let's say str is something else. It's a struct s ping str, like so. And when we create this thing, we need to calculate the size first. So let's say we have a size of struct s ping and we have let's see, so let's say we have 4 bytes for the data, something like this. Now we malloc size bytes instead, and we 0 size bytes. And now we need to fill in these two fields. So let's start with the ID, and let's say we set this to, I don't know, 5,000 perhaps. This can be anything really, any 16-bit number, but we need to put it inside of the right byte order. So we need to do this. And then we have the seek, and same here. And let's start with a 1 here. And now instead of copy to the str, we are going to copy into str data. And we have 4 bytes or 3 bytes and a 0 byte at the end. So let's just send ABC like this. So this is our new payload. And when we make our icmp, we need to make sure that we use size bytes. Okay, I think that's it. So let's try this again. It's not a string anymore. We need to change the cast. So this should be a struct s ping, like so. And same there, but the other way around. So when we zero it out, we need to turn it into an int 8. And now I think it should be good. No. Okay. It expects a series of bytes when we create it as well. So let's cast this like so. And let's jump down a little bit here. Alright, so let's see what happens when we run this thing. Okay, no error, it's good. Now we have 8 bytes of payload. Alright, so if we look at this, there's a packet from this IP, icmp echo, the ID is 5000 and the seek is 1. And the length here is the length of the entire icmp packet. We can send our packet, and next time we will finish this thing. And maybe after that we can start building some really cool stuff with this kind of logic. So I hope you liked this episode. Please like and subscribe. And hit the bell icon if you want to know when the next one pops. Thanks for watching. Thanks for today.